Well, good morning, everybody, and welcome to our webinar Wednesday today. Happy Wednesday. It's warm here in Fargo, so that's exciting. Today, we're really excited to hear from Margot here in the state office, our STEM specialist, and also Brenda in Stutsman County. They're going to talk to us about the STEM challenge, the edible engineering experiment. And look, there's chocolate involved, so why would you not want to learn about that, right? So get excited about that today. And then also, just a little commercial. There's another webinar Wednesday next week with Erin Bain from American Income Life Insurance. I'll be sending out an email about that probably tomorrow. And then on the 22nd, there's one with Stacy Winter about contracts. And I know that's during the support staff conference, but that will be recorded. And then on May the 20th, Samantha Lawman is going to be talking about fairs and achievement days. So we have three other professional development opportunities coming up really soon within the next 2 months. So all right, well, I'm going to turn it over to Brenda and to Margot.
Well, thank you, Megan. Again, I'm Margot Bowerman. I'm the North Dakota State STEM specialist, and happy to bring this opportunity to you. It's what I will say is the sweetest professional development you'll ever be involved in. But Brenda, my co-chair for the STEM team, I'll have Brenda introduce herself.
Well, my name is Brenda Jarski Weber. I'm the FCW agent here in Stutsman County. Our office is located in Jamestown. And I actually came to Extension only 4 years ago. I was a 4-H program assistant here, and then I moved into the FCW job. I was wildlife field biologist for 20 years prior to that. And in the winter, when it was cold, I would go to part-time and then I would substitute teach. And STEM really became a passion for me. I was raised by parents that always really helped us if we had an interest to fulfill it. And so when I took this job with Extension and became part of the STEM program planning team, I really want to make STEM accessible to the youth and to the adults that facilitate it. And it's very possible, but a lot of times when people hear that whole science, technology, engineering, math, it's frightening. And so we're trying to make it accessible and fun and give not just kids, but leaders the courage and confidence that they can do these activities.
Thank you, Brenda. Well said. Well said. So I'm going to get us started with a little engagement. This well, I don't know why that one picture isn't showing up. This is my dog Rubik's Cube, and he's quite a character. So I'm just kind of checking the temperature of the room. And how are you feeling today with these pictures? So um, I would say I'm probably number five, where he's rolling in the grass with his frisbee next to him because he's just pure joy to be out in the grass and pure joy to be out and playing with you. So I'm excited to bring to you the edible engineering experiment all about chocolate. So that's how I'm feeling today. So go ahead and throw that in the chat or unmute. Or Brenda, how are you feeling today?
I'm actually a 7 because I'm kind of like looking at this, and I told Ashley, our A&R agent earlier, I says, I'm a little nervous. If I was doing this in person, I'd be good to go, but the whole Zoom thing and kind of looking through the window at everybody feels different for me.
Thank you, Brenda. So how's everybody feeling today on a 1 to 8 Rubik's Cube scale? One and a two, right? A seven for Megan. All right. Three for Melody. All right. Love it, Carrie. Yeah, I don't know that the cat appreciates his playing, but they are playing. A five for Kennedy. Nice. And a one for Carrie. All right. Yes, he's being a goof there, carrying the bucket, but trying to be helpful. Well, I appreciate you participating in the Rubik's Cube metric for your feelings today, but we'll get moving on. Just nice to know how people are feeling today. So our plan for the day is, if you were on 2 weeks ago when we talked about the chain reaction machine, we have a lot of offerings here in our STEM team. So we're just really trying to clarify what we mean when we're talking about our STEM challenge. So we'll quickly touch on that. Then we're going to dive into exploring our edible engineering experiment, and that will include what we hope young people are learning, a little bit about the engineering design process and why we're focusing on that, and then just some hints and some excitement about what to do when facilitating the activity. And with that, I will turn it over to Brenda.
Okay, so I will clarify the challenges, but I'm going to start with the North Dakota 4-H program planning STEM team. There's so many options. And so we're focusing on two areas, which is engineering and energy. And so what we're talking about today is engineering, and we're really trying to make engineering accessible to people. I have a definition here that says engineering is the practical application of science, mathematics, and creativity to design, build, and maintain structures, machines, systems, and processes. It focuses on solving complex real-world problems efficiently and safely to improve daily life, ranging from infrastructure like bridges to technology like software. And that's from the American Council of Engineers. You read that, that's intimidating. You throw out words like complex and maintain and practical application. But then when you look at the aspects of engineering, there's problem solving. And Margot gave a great example one time. I can't remember where we were at, but she problem solves in the morning when you get up and decide what you're going to wear. In North Dakota, that can be a challenge because we can have all 4 seasons in one day. So you're problem solving. And then another aspect is application of knowledge, innovation and design, and safety and economics. So if you really break down engineering, it's using what you know to solve problems to make your life better. That's a lot less intimidating than that first definition I read. And so, as Margot said, the Chain Reaction Machine Challenge was covered a couple weeks ago. I know that's recorded. I went back and watched it, so you're welcome to look at that. And then we're going to dive into the edible engineering experiment today. And there's also the ball run challenge. You can see that sheet down on the bottom. So that's another opportunity to teach kids about some engineering and design using very basic materials. I was looking at this morning. The construction materials are paper and tape and a flat surface. You can't get much easier than that. And then scissors, ruler, pencil, tape measure, meter stick, stopwatch, and ping pong ball. So if you're interested, you can check that challenge out also. And then we can go to the next slide. So the North Dakota 2026 STEM Challenge Edible Engineering Experiment. This is actually to take the place of the National STEM Day kits that we used to get. I know some of you probably remember them. Lindsay Leaker had a grant where they would send out these kits to the counties. The last 2 kits were fantastic. I was like, man, they've really figured out what they're doing, and then they went away. So this is to take the place of that. And you can't go wrong if you have chocolate and engineering and design and get a chance to teach about bridge design and welding. So if we can go to the next one. So there is a curriculum for this, and the challenge is to build a chocolate box girder bridge that must support added weight. And it's a simple project. We're going to get into some facilitation tips a little bit later, but I've done this with 3 groups now, and then we did have a STEM retreat for the program planning, and that was the first time we got to play with chocolate. And when people first hear the chocolate welding or chocolate bridge and they don't really understand what we're doing, but then when they see it built, they're like, that is such a cool project to teach kids how bridges are made. It has in the curriculum all the different, not all the different careers, but a lot of the different careers that are used when you're doing a bridge or any engineering. This is a really great way to introduce kids to careers, more than one career. There's everything from a heavy equipment operator, welder, civil engineer, structural engineers. I used to work as an environmental scientist, where you would have to go in and do the environmental studies. When I worked on wind farms, the site engineers were the ones that made that project go. They were the ones that determined where the turbines would go. The same thing when I worked on pipelines. Every time that a pipeline was redone, it was given an alphabetical designation. So you would start out with designation A. And as the engineers worked through where the path of the pipeline would go, the one pipeline I worked on was up to NN. That's how many changes had gone through the site engineers. So there's a lot of opportunity to introduce the kids to the concept of engineering and design and possible careers. Okay, next slide. And here's what we hope the youth learn. The skills, that problem solving I talked about earlier. And I noticed Margot changed the picture. Maybe they can solve a problem where they can build a box girder bridge and actually hold that poor cat up in the pot there. Critical thinking. Critical thinking is one of those things that with AI, people are really worried about. Are kids going to be able to learn critical thinking skills? Well, if you do this particular activity with them, yes, they're going to learn the critical thinking. Communication. When we went and visited the Blue Flint ethanol plant, we were in the control room with a lot of different workers, and they were from college interns all the way up to their older managers. And we asked them, what's the most important thing about your job? And they all said communication. Communication's kind of becoming a lost art. So this teaches kids how to communicate and collaboration. I've always done this particular activity with teams, and collaboration is really, really important. And then creativity. Kids are incredibly creative, and this gives them a chance to build something with simple materials and use their imagination. And we want to give them knowledge of the engineering design process without making it intimidating. And you can also lean into it depending on what your strengths are into either the bridge design or the welding. So there's different aspects that you can really highlight. So Margot, I'll turn it over to you.
Thank you, Brenda. And as Brenda's, those skills and the knowledge, but really more the skills. When we do engineering programs as a North Dakota STEM team, we build in all of those things. So that's what I don't, great if kids want to go into the engineering field, but those are the skills when young people engage in our engineering program. Those are the skills I want them to be able to identify that they've gained through the engineering process. So what is engineering? Brenda gave a definition. I'm going to even maybe simplify it a little bit more. And I'll be honest, when I heard that 4-H and I was going to need to be tackling engineering, and my brother is an engineer, he's a mechanical engineer, and he's one of the smartest guys I know, and he can tinker and he can put things together. So I was really intimidated when I realized we were going to be doing engineering. But then when I really started doing engineering and understanding what engineering is, and as Brenda said, it can be complicated, but it's also at its essence, engineering is defining a human problem that leads to designing a solution. And I will use my example that Brenda indicated as we go through an engineering design process, because to me, it's an illustration of I can ask each of you, did you solve a problem today? And I guarantee you've already solved a problem today. And you've probably solved it using some type of engineering design process, but engineers call this out and do it intentionally. And that's what I want our young people to realize is they solve problems every day. And when we do it with intentionality, just like everything, if we do things with intentionality in our lives, we have good results. We meet our goals. So the other important thing about engineering that I love, and it's like the magic sauce to do for me to do a STEM programming with young people, is when you do engineering, there is not one correct solution. There's maybe some ideal solutions giving your constraints and your limitations and what you have. But because there's not one correct solution, we have to, it's an opportunity for young people to know that sometimes we fail, but also one person's solution might be the best solution for another person. So we're teaching them that there's more than one way to solve a problem, and their way that works for them is the right way. So diving into the engineering design process, and I'm a true believer in this process, and it's a 5-step process. And I'll show you some other examples, or I'll show you an example at the end that people put different elements into this process, but at its core, these are the elements that are part of the engineering design process, and we'll walk through these. But one of the important things about the engineering design process, and that's important with engineering, it's not a one and done. So if you think about often we get, or I'll often get questions about fair projects, and somebody has maybe built a Lego project. Which category does this go in the fair? My son or my daughter has built this Lego project. So for me, it's engineering. If they've gone through this process, they've understood that they had a problem to solve. They've gone through the process of designing solutions and testing solutions. But critical in there is that they've needed to have tested it and make some adjustments. If they're just building based on a set of directions, to me, that's a craft project. But if they're engineering a Lego project to solve a problem, that to me is an engineering project. So we'll go through the steps in this, and I'll go through kind of quickly because I don't want you to get hung up on it, but I want you to see it as a problem-solving process that allows young people to believe in their own capabilities to think critically and solve problems. So the first step is asking what the problem is that we're trying to solve. So in the example that I almost always use is every day I have a problem of what am I going to wear? So that's my problem. What am I going to wear today? And we introduce the term constraints to young people so they start to get this vocabulary. But what are the constraints? Constraints are limitations. Another critical part of this step is to understand what success is like. And don't we all need to start a project understanding what success looks like at the end? So for me, I have my constraints are I want my clothes to be clean, and my success is if they're clean, they match and they fit. So those are my constraints, but also how I know I'll reach success. So I've defined my problem. I understand my constraints, and I understand what success looks like, at least for me. So then the next step is to actually start brainstorming some solutions. Use your imagination to design solutions to the problem. And there may be a variety of solutions. In my particular example, I can look at my closet. My closet has my clean clothes, so I'm not picking things out of the laundry. I'm using clean clothes. I might have a couple of outfits I want to try together, but I'm going to pick one to try. The next step then is to make that plan. And this is honestly, when I work a lot of times with young people, if I've got plenty of time and I want them to go through this process, they will often, and don't we all kind of skip the planning process? But the planning process is an important one, and I will force them to go through it the next time they do it. And by asking questions like, what would be different if you'd actually spent some time planning? But it's also really important to plan if you have limited materials. So that might be when I might force young people. And in this activity, because chocolate can get expensive when you're working with a lot of young people at once. So in this one, I might ask them to actually do some planning before we actually start the building. But in my case, I pick out a couple of outfits to try on, put them together, and then the next step is actually the building part, the creating and building. So I try on an outfit and maybe this one doesn't fit so well or that doesn't quite match. But I try on a couple, and then to that last step, and of course the fun step is always the creating and building. But then for me, where you really get the critical thinking part in, it's when you get to the improved step. So I look at my outfit. Okay, what's working in this outfit? What's not working in this outfit? Maybe these don't fit. Maybe these don't go together. So I might try on a different outfit. Or in the case of doing a Lego example, maybe some piece isn't meeting what I had for my success criteria. So I'm going to rebuild again. But the important part of this is, one, it's that critical thinking. They started one by identifying the problem. Then they're going through this process and they're applying critical thinking and then going through problem solving again. And when we do these projects and ask them to work in teams, that's when we build in that collaboration. And then of course at the end, we're going to ask them to share out their projects. So we're giving them that opportunity to communicate and do some public speaking. So this, in essence, is what the engineering design process is. And the diagram on the left is what comes from North Dakota as their engineering design process that they teach in schools. So it's clearly more steps in there, but in the essence, ours is a little bit simpler because those pieces are all contained in there. But I want you to see that what we're doing in North Dakota 4-H is connected to what's happening in North Dakota in schools. So I'll turn it over to Brenda because she has quite a bit of experience in facilitating this with young people.
So I'm just going to, on this portion, I'm just going to tell you the materials, and then I'll dive into some tips and tricks that go a little bit more in depth with the materials through, like I said, our tried and true part of the process, improving it every time we go through it. So the materials are pretty basic. You need chocolate, the full-size bars, and ideally different types. What I have done is I have gotten the milk chocolate, dark chocolate, and then I try to get either a dark or a milk chocolate that has foreign material in it, like chopped almonds or toffee bits or something. You'll need a container for water. The welding is done with hot water. It doesn't even have to be like boiling hot, just hot water. Weights or cans, the ones that seat in themselves, like at the beginning, the video in the beginning had the Progresso cans. Those work nice because they don't slide off of each other. Books or cans to hold the bridge, and then paper or plastic to cover the table. And what you want to do is connect youth to what they know. Highlight engineering as you go. Ask questions throughout. Ask them, do you know anything else that might bear weight besides a bridge? Keep them talking and thinking. Provide options for continued learning. And I'll go into that a little bit more with one of the pictures coming up. And then connect to workforce skills. Like I said, there's a whole list in this curriculum of different careers that go into building a bridge. So if we can go to the next slide and show some examples of bridges. I like this slide when you're letting the chocolate set up. I'll get more into that in just a second here. But I like this slide because it gives a chance to ask the kids, do you see any different materials here with these bridges? Do they all look the same? What kind of structures are they? What kind of thing are they spanning? What does the footings go into? What is a footing? It gives you a lot of opportunity to ask questions and get kids to really notice things. And the next slide is really cool because it shows a bridge or two bridges being built. I showed this slide at our youth activity day, and I had a young man look at the bottom right, and he's like, hey, that's what the Memorial Bridge in Bismarck looked like when they redid it before they put the road on it. I was like, that's right. That's exactly, what we're going for here. So he was able to connect what we were doing with the chocolate to a real world experience, which is what we want the kids to do. So now on to facilitation tips. And this is a picture from our youth activity day. And as you can see, that was not a staged photo. That was two of my clover buds that were just in awe that chocolate could hold as much weight as it did. But one thing that we have learned is to handle the chocolate with care. When you're purchasing the chocolate, you can feel if it's broken or not. Dark chocolate, in my experience, tends to be very fragile. When my husband and I were picking up the chocolate bars for this, we got all the way to the checkout and we're halfway done checking out. I was like, this bar is broken. So is this bar. So he's running around trying to replace bars and everything. We could have saved that stress if we would have just checked the bars when we were standing there. The other thing, like I said, dark chocolate seems to be really fragile. So we use scissors to cut the ends off the chocolate and then a small pair to just slit the package up the middle. So it's not breaking when you're trying to kind of manhandle that wrapper off. I always have the youth wash their hands because they're working with chocolates. I told them, well, you can eat the bridge when you're done. So make sure they wash their hands. The type of jar that we use to melt the water, like I said, you just put hot water. This is my favorite jar right here to use. This is actually a 1.5 pint, the wide mouth jar. It's got a nice level surface. Danielle Dinger did this for a STEM activity that we had at the University of Jamestown for middle school kids, and I think this was actually her favorite jar. That's the jar that's actually in the picture here. Once again, nice flat surface. You can use a bottle. You could also use one of those cylindrical vases. I do like jars because they seem to hold the water temperature a little bit better because they're a little bit thicker. My personal favorite jar are the Atlas canning jars. They haven't made those for decades. They're a really heavy jar and they're nice and square. And like I said, you don't need boiling water. The kids should not be burning their fingers on the jar. It just needs to be warm enough to melt the chocolate. My middle son actually came and helped the girls at Youth Activity Day build this bridge, and he's 22, and he's like, Mom, there's no way that water's hot enough to melt the chocolate. It's like, have a little faith in your mother, Noah. And we got done. He's like, wow, you were right. That worked really well. So it doesn't have to be scalding hot. Like I said, you don't want the kids to be burning their hands. Planning for time is really important. I have been telling the kids I'm not a patient person. Patience is everything. This is not an activity you can squeeze into a half-hour time. Our youth activity day sessions were 1 hour and we had 15 minutes in between sessions. The kids ended up using the whole hour and 15 minutes. You want to make sure that that chocolate weld sets up and it holds, which leads me to the next part of the facilitation tips is your temperature of the room. Make sure you don't have the heat blasting. This particular day that we did this session, it never got above 0, and this room happens to be by 2 outside doors, so it was getting a draft in there, so it was keeping the room cool, which played to our benefit. I know, Margot, when you did it with Sue Isbell, it was quite warm in the room. And when Danielle did it at the University of Jamestown, it was a beautiful day, and she was in a classroom with south-facing windows, and it got hot in there. Your chocolate will give. Like I said, that weld will not hold up real well, and it tends to want to collapse. So make sure you keep that temperature of the room cool. Spark ideas for things to try on their own. The two young gentlemen in the back were telling me, we only have 4 bars of chocolates. But a pyramid, a triangle shape would actually be stronger. So if we had 6 bars of chocolate, and I said, well, you get 4, but you can go home and try that on your own and report back to me and let me know if doing a triangle girder that are interlocked works better. So when kids start asking questions like that, you might not always be able at that moment to help them, but challenge them to go try it on their own and then to let you know. They love coming back and reporting back. So spark their ideas and then be intentional. I think I said this earlier. Focus on bridge design, or maybe you have some kids that are really interested in welding. I did this with my 4-H club, and I have several kids that are interested in welding more so than the whole design. So I asked them, well, what type of welding do you think would be used on this? What are the different types of welding? You know, there's stick welders, there's MIG, there's TIG, there's wire fed. I only know that because my husband welds. I tried welding once and I screamed, which is not a good look for a welder. But find out what they're interested in. And if you find that you have some young people that really are interested in welding, maybe try to get a welder to come and speak to your group. Maybe if you have an engineer, we happen to have our council president is an engineer. Invite them to speak when you're doing a youth activity day or a club meeting. And then the big question, to jig or not to jig. The best of these chocolate box girder bridges have 90-degree angles. And in the curriculum, it shows how to make a jig with a margarine or a butter container. The only thing is you're not going to want the kids cutting that 90-degree angle because box cutters that are sharp and kids don't always mesh really well. So one challenge you could give the kids instead of having them cut something is what would work well to make a jig? I think a shoebox would make a fabulous jig. It's a nice 90-degree angle. It helps them get that strong joint that you're looking for. Did I miss anything, Margot?
No, you hit on it well.
Okay.
Well, and please, we'll have definitely a formal time to ask questions, but pop in and ask questions at any time. And we're getting near the end here. So as we think about where can we do this activity, there's a variety of places. I think planning the time is the most important thing. This what to do while you're waiting for that weld to set is an important thing. And I'll say this too, as we've been going through this activity has been on my radar for over 10 years when the Welding Association came to a 4-H meeting that I was at and said, we need welders. So we're developing this chocolate welding activity. And I thought, that's great. But then I really couldn't find it anywhere. And I found this one from the United Kingdom is where it came out of. But when I teach this to adults, when I teach this to other fellow educators, I teach it as a curriculum to with that intentionality in mind. Because although this comes from the Welding Association, there is nothing really about welding in there. So if you want to teach about welding, I think there's definitely an opportunity to bring in that welder. In fact, there's a youth group that I work with here in Fargo that has a welder as one of their volunteers. So I think I'm going to pilot that with this group. But there's tons of places to facilitate it, but you need that. Another thing that lacks in the original curriculum was you need to build in time for that weld to set. So some of those things that we learn as facilitators are we're missing in here. So it was also a good opportunity to how would you take this curriculum and improve it? And my hook was it's chocolate, so come learn about chocolate welding. But it was a way to teach how do you be intentional with your lessons and what do people need to know to facilitate the lesson. So all those things that Brenda went over are really things that we've learned through doing it with young people. But places that you could facilitate this, chocolate welding attracts people. When Danielle did it at the STEM Activities Day, her sessions were all full. People were really attracted. Kids, middle school kids, were attracted to come do something with chocolate, and it is really impressive. And think about those knowledge and skills that we're giving to young people. They're coming for chocolate, but they're learning that problem solving, critical thinking, collaboration, teamwork, all those fun things. So there's tons of places that you could do this, but keep the time in mind. It takes probably 30 minutes to actually do the activity, but you've got to give it almost that much time to allow the weld to set to really get those dramatic effects. So Brenda did it at an activity day. Again, an hour is probably the minimum. What worked perfect when I did it with Sue, and it was a school setting, so we had that advantage of the kids came back. We tested the next day, and that really worked well. Certainly could be in an after-school program, and if you're doing it weekly, I'd save it till the next week if you can protect those chocolate. It's a great 4-H club activity. People could take it home and test it. In fact, when we were developing this activity, it was during COVID, so we did this all at Zoom. It was a nice activity to do via Zoom, and that allowed young people to make the box girder bridge, but then allowed them to let it set for a while and then test. And I asked them to take pictures and videos, and I have some awesome pictures and videos of kids doing it, just like that picture that it was at Brenda's activity date where there was the surprise with the young person. Almost always you will get that type of surprise. They don't think it's going to hold a can or a rock, and they are super impressed when it does. Brenda's working with some homeschool groups and thinks it's a nice activity, and I would agree to do with a homeschool group similar to a 4-H club activity. They can then kind of prolong that time for it to weld, so they've got time for it to set. I think a library program could be done at as well. But again, that chocolate welding, that concept is a real attractant and could be a nice recruiting tool.
Margot, I did forget one thing on a facilitation tip.
Go for it.
Table cover.
Oh, yeah. Yep.
I
We've
found
learned
that out the hard way. Dark chocolate does not come off of those white banquet tables very well. So that would be one thing that I would recommend. What we did find works out really well, freezer paper. It's heavy enough where it lays flat and it pulls off really nice, but I would definitely recommend covering your table with something because that chocolate gets messy.
Good idea. Yeah. And probably obvious, but just in case it's not, don't use anything that's glass for your weights because you can stack things quite high, and when it crashes, it truly crashes. And I did it once with a brick on a wooden table, and I have a little dent in the wooden table, so it's a crash. But with that, what questions do you have or might you have?
Hey Brenda, I have a question for you.
Yes.
I thought it was really interesting you were talking about the different types of chocolate. You said you use like the dark chocolate and the milk chocolate and some of them are fragile or not. Well, have you tried like the baking chocolate bars or anything? The ones that are in the baking section?
I have not tried that, and I think it's just because of the edibility aspect
Hmm.
of it. I know when we did it for the STEM retreat, Margot had gotten some of the cookies and cream bars, and they're a much thicker bar, but they did not work very well at all. And the ones that I found, and I am not promoting any product, but the Walmart brand cocoa solid or milk chocolate with 30% cocoa solid have consistently been my strongest one. The dark chocolate breaks, and anything that has that foreign material in it, like your chopped almonds, seems to weaken the structure. which is a really good talking point with the kids. If that's the first one that breaks or holds the least amount of weight, that's a really great way to say, what does this show? What if there's an impurity in your metal? So it's a really good talking point, but I have not used the baking chocolate yet. I thought about it, but the kids like to eat it.
Right, right. I just was like, oh, well, I didn't know if you tried those, and I didn't know if they were stronger, or however it
Yeah,
worked.
good
Yeah.
Maybe
question.
I could segue into a baking lesson with our, the box girder. It's like, okay, well, we're not going to eat this, but we'll bake with it next time or something.
But it's those type of questions, those curiosity questions that I know, and we get them from young people. What if I tried this? If we're getting them to ask questions, we've sparked that curiosity. So love that question, Megan.
I even had a question with one of my younger 4-Hers when we did it for our club meeting. I says, you want a good 90-degree angle? And my 4-Hers all of 8. She's like, well, what's a 90-degree angle mean? And so then I showed her, and she insisted on doing it. She did not want her mom to help her. And she sat very patiently, much more patiently than I am even at my age, until she got that 90 degree. So there, it just sparks more and more questions. And that's really what we're looking for. It makes it accessible, like I said. When they start asking questions, they're not afraid of it anymore.
So I was wondering, did you give them all the same kind, like the 4 bars, all the same kind of chocolate, or could they intermix it if they wanted? I'm not sure if you did it that way.
I've always allowed them to choose. So typically I think in all the times that I've done it, they've all chose the same type of chocolate bar. So like for chocolate with almonds or for regular milk chocolate.
When I did it, I had 3 different kinds of bars, and they were covered on the table, and the kids had to pick a team, pick a table, and then that's the chocolate they got. And they had to work with what they had. So there's a lot of different ways that you can do that. You could have them, draw a number out of the hat, and that's the chocolate they could get. When I did it for Youth Activity Day, I did end up having the same chocolate just because all the bars when we went to the store were broken. There was only one, the milk chocolate that was 30% cocoa solid that wasn't broken, so that's what we ended up using.
The other thing I've frequently done during testing is with my phone doing the slow motion. So I'll take a slow motion video. So then they can also put their critical thinking hats on again, and we'll review the video in slow motion to see where it failed. And then that'll lead to, well, what would you want to do differently the next time? So again, sparking them to think through the engineering design process, even if we're not doing an iteration or another round of the engineering design process.
I had my one team during Youth Activity Day where their bar broke in half, so they welded it together. And then as a team, they decided, well, do we want that to be a side support or the bottom support or the top support? So they were talking through, where's the least amount of pressure going to be? And they decided it's not going to be on the sides. So they ended up putting it on the top, and I think they ended up holding 12 pounds on that bridge.
Love the critical thinking.
And that again is that collaboration. They talked it out amongst themselves. There wasn't
Mhm.
one person that made a decision. So you're getting that communication, collaboration, problem solving, critical thinking, all kinds of things going on.
Well, if there are no more questions, but please do ask if there are questions. We're curious today, if you feel more confident in teaching this activity or leading, facilitating this activity, or maybe even just a little more confident in leading in just a general engineering project or activity.
So I had been like a science teacher before this, so I'm just gonna say thank you. I really love having the other ideas on how you maybe like got them into the groups. That was very helpful. And just a little bit of the tips too about what you've already found out always helps if you've not actually done it before. So thank you very much.
Thank you, Carrie, for sharing.
And it's okay to tell the kids if maybe their bridge cracks right away and it doesn't work right away. Because I told them when I used to work on wind farms, it was over a span of 12 years. I says those turbines were constantly changing. They were constantly making improvements. You might not see them just driving by, but I would be talking to the technicians and they would, oh yeah, we're changing the blade pitch. We're doing this, we're doing that. So it helps when the kids realize that just because it failed once, what would you do different the next time? And it's not a way to fail. You always pull out that Thomas Edison quote. I didn't fail 2,000 times. I found out 2,000 ways it didn't work.
Yeah, doing it at a county fair, it's a good goal. I think, yeah, let's talk about that. That some of the challenges I see are one, typically at a county fair, in my experience, and maybe you're thinking of it differently, and even a half hour to get people to stay there and do something for a half hour would be a challenge. So how could we modify it so that it is maybe more of a quicker activity? And then just generally the heat at a county fair. And as for the freezing it, I'm not a patient person, so when I have done this, I've actually taken mine and put it in the refrigerator to speed up that cooling process.
Do you have a link where you put all this on a Google Drive or anything to share?
Yeah, I thought about that after I'd already started doing the
Oh,
slides. So yeah, no,
I understand.
it is on our website, and I don't know if I share it, it will show you my computer desktop that I'm embarrassed to share because Megan, if
I'm
you
right
think
there.
yours is full,
I'm right
mine
there
is
with you,
too.
Margo.
Yeah.
No
So
judgment.
yeah, you can find it. We have it on our state website. If you I think probably if you look up chocolate welding or edible engineering experiment, it'll find you. But it's also in our Google Drive in a couple of different places.
And if anybody does think of any questions afterwards, I mean, you can definitely reach out to us and we can try to answer them. Or if you find an epiphany, let us know because that's how we find things out through trial and error.
Well, thank you everybody for joining us today. It's been a really fun activity to do. Until I moved to North Dakota, I'd kind of reserved it just for training staff. But our STEM team liked it so much, and with the absence of a national STEM activity, we thought, why not? Like, it's fun for adults. We know it'll be fun for young people, and it has been.
Yeah, thank you, Brenda and Margo, for doing this today. It was really interesting. I learned a lot too. So thank y'all. And then don't forget, next week we have the one on insurance, American Income Life Insurance. So watch your email for that. That'll be sent out this week. So thank you everybody for attending today.